Hello, I'm Daniel Campos-Zamora from the University of Washington, and on behalf of my collaborators, I'll be presenting our project Nightlight, passively mapping nighttime sidewalk light data for improved pedestrian routing. But first, I'd like to begin with a question. Which one of these two options would you rather walk on? I'd go with option A. It seems lively, well lit, and more interesting. Now, how about these two? I think most people would pick option B, since it's a better lit walking path. But what about these two options? Chances are this is a harder question. Information is missing from this map that could inform your route planning. And one of these signals that's missing is the lighting condition. Now we know that walking can provide numerous physical, mental, social, and environmental benefits. And people may base their decision to walk at night if they know there is a well-lit path to their destination. Without information on lighting conditions, people can either end up in uncomfortable walking environments or simply choose to avoid walking at night altogether. And different populations are impacted by this differently, which can lead to unequal access to public space at night. Currently, there are various methods for estimating lighting conditions in cities. For example, satellite imagery can capture the lighting across large areas, but is generally too coarse to inform what pedestrians would experience on the sidewalk. And some cities have databases of streetlight locations, but these don't always account for outages or additional ambient light that may come from other sources like businesses. It is hard to capture the light level that's experienced by pedestrians. Another option would be to use handheld light sensors that can measure streetlight conditions from the point of view of somebody on the sidewalk. However, this would be expensive and time-consuming, which makes it hard to scale. However, the technology that's in these commercial light meters is already in all the smartphones. It's basically just a computer and a light sensor. This means that the technology to sense light's already in the hands of over 4 billion people. Now for Nightlight, we see this as an opportunity to passively crowdsource light level, since these sensors are already in the proper orientation to measure overhead lighting conditions on the sidewalk. Now combining that with additional sensor data, like the IMU and GPS, we can map the light level. The question then becomes is how can we leverage the ubiquity of these sensors that are across the built environment to aggregate and analyze light at scale? Well, first, we have to evaluate the ambient light sensors in the various smartphones to see if they can compare to the commercial light meter for this task. We set up a lab experiment in a dark room with a dimmable light source and a motorized gimbal to control the phone position to compare it against a commercial light meter. We tested across 4 smartphones by recording the lux reading during a sweep using the gimbal to characterize the differences in performance. These heat maps show the lux value readings varied across the sweep. Now phones have a different refresh rate, which can lead to smoother or coarser heat maps. And now while there are differences across smartphones, we found that on aggregate, they do perform comparably to the commercial grade light meter. Based on the positive results from the in-lab study, we did an on-street evaluation by walking along a street and measuring the light level data as we passed a street lamp. Now these density plots show that we read the higher light values more frequently, but we're directly under and right after we pass the street lamp. So by tracking the walking direction and heading, we can approximate the light location. For more details on how we process the data and the validation, we encourage you to read our paper. We then scaled up our data collection to 3 different neighborhoods in Seattle. The research team and 1 additional volunteer walked a total of 16.8 kilometers at night across the 3 regions. We aim to capture locations that vary across lighting, zoning, and geography. For example, the gridded neighborhood ensures that the walking routes are all equidistant. The waterfront neighborhood offers a pleasant waterfront walking path, while the residential neighborhood is zoned primarily for single-family homes, while the other 2 neighborhoods have more of a mixed-use zoning. We used the neighborhood data collection to run a user study to investigate how light level data impacts pedestrian behavior. We ran a user study where users had to draw their walking route between 2 points on a map and talk aloud about how they are planning their route and what influences their preferences. We found that light level data plays an important role in how pedestrians choose their walking path. For example, here we see the participants' walking route without seeing the light level data and how it changes after they're presented with the Nightlight map. In this case, we see that some participants chose a walking route that was over 1.5 times longer than their original route to walk along the well-lit path. We found an even bigger impact in the gridded neighborhood where the routes have the same distance. Here we show the diverse set of routes that were generated by the participants before seeing the light level, and how after seeing the light level, most participants preferred to walk along the street with the most light. And this was also reinforced during the Think Aloud session, where one participant said that if I had to walk at night, my primary concern is whether there is enough light. And overall, we see that 50 out of the 72 routes changed after being presented with the light level. So we show that people actually change their behaviors to prefer a well-lit route after being presented with data from Nightlight. Now, we acknowledge that we had a limited test pool, both in the terms of geographic region and the users that we studied. So for future work, we plan on deploying this at a larger scale over a long period of time to capture how Nightlight could be used out in the wild. Now, the route drawing task might not be representative of an actual walking route, so we plan on building a routing app that can integrate light level when suggesting a walking path. Lastly, we were limited by the phone operating system so that you could only get the lux value. However, in the future, we could try to integrate more sensor data like cameras or the rear-facing ambient light sensor that's in newer models to improve the data quality. And thank you for listening to our talk on our system Nightlight.